a unique combination of both lift and propulsion. Background of the invention, left bracket 0002 right bracket, referring to Fig 1, the spacecraft has a hull, in the shape of an equilateral triangle. A parabolic antenna is centrally located in the bottom of the hull. An array of horizontal slot antennas is located along the side of the hull A. Each backcomer FG has a corner conducting plate which is charged to a positive voltage plus V. The forward corner C has a conducting plate charged to a negative voltage V. A motion control hemisphere D is located on the bottom surface in each of the three comers. Left bracket 0003 right bracket, referring to Fig 2, two planes AB intersect at the origin O at an opening angle I. Each plane XY is charged to a voltage V. The potential at point P is determined in polar coordinates, P less than vertical bar greater than. The Laplace equation for the potential less than I greater than in polar coordinates is given by LA less than I greater than underscore P less than 9 PVDPJ plus P 2 dip 2, which in mm means that the coefficient A of the cosine term has to be 0 in the solution above. Choosing B equals 0 makes the general solution for the potential equal to less than I greater than P equal V 4 MP mly /UMJI less than H/P, which shows that when the angle is 0, the sign is 0 and the potential is V. If the angle is 3, then there is a multiple of G, such that the sign is 0 again. Left bracket 0004 right bracket, because the series involves positive powers of the radius, for small enough P, only the first term M equal 1, in the series is important. Thus around P equals 0, the potential is approximately less than greater than, P4 greater than VH, 7P, vertical bar, synonym vertical bar greater than /P, left bracket 0005 right bracket. The electric field component is the negative gradient of the potential. 1D less than ampersand na /E4 P equal X tilde P 0 cos pip pop P. The surface charge distribution at less than vertical bar greater than equal 0 and less than vertical bar greater than equal left bracket 3 is equal to the electric field perpendicular to the surface times the permittivity of space E0. Using a separation of variables solution, the potential is given as the product of two functions, A greater than, P less than vertical bar greater than equal asterisk Pj less than vertical bar greater than, which when substituted into the Laplace equation becomes PDF drive vertical bar L underscore RDP /DP plus dF2. Since the two terms are separately functions of P and 4 greater than respectively, each one has to be constant, with the sum of the constants equal to 0. PD/drive underscore 1D2VR pi dpjvd less than PA2 /5IA P equal EOE P 0 equal. Notice that if angle of intersection vertical bar 3 is less than it, then the equation says that there is a very small radius to a positive power, which means little charge density accumulation. Left bracket 0006 right bracket, referring to Fig 3, the value of 3, in the case of the triangular hull, is equal to 360 less 60 for a total of 300 or P equal 300 181, P3. These two equations have solutions. If P equal up V plus BP underscore V up less than J greater than equal 4 cos V vertical bar plus 5 sin VJ, the azimuthal angle left bracket is restricted to a value in the range 0 equal less than vertical bar equal 3. The boundary condition is that the potential less than I greater than is equal to V for any radius P, when less than left bracket equal 0, and less than left bracket equal vertical bar 3. This means that V has to be an integer value of it so that the sign function is 0, which says that there is a charge density singularity to the 2/5 power for small radius. Thus the comer plates on the hull create a huge line charge density along the sharp vertical corner edge. The equation for the potential of a line charge density is given as y equal r caret ln junior x0f plus yy0f. 2ns0 sin vf3 equals sin caret g slash sj equals sin slash wr equals 0 m equal 1 2, where x is the charge per unit length in the vertical z direction, and x0 and y0 are the location of the line charge in the z plane. July 6, 2006 left bracket 0007 right bracket, referring to Fig 4, the triangular hull D is plotted together with the potential contours A and the electric field arrows B, created by the three corner line charges. The line charges are perpendicular to the paper. Notice that the electric field arrows are parallel, crossing the center parabolic antenna C. The electric field is also parallel to the sides D of the triangle. Left bracket 0008 right bracket, referring to Fig 5, along the side of the triangle A, an array B of horizontal slot antennas emit electromagnetic waves that have a vertically polarized electric E field C. These traveling waves interact with the electric field D, produced by the line charges, on the comers of the triangle, left bracket 0009 right bracket. Using differential forms mathematics, this combination of fields is represented by the Hodge star of the differential of the wedge product of the two fields. The antenna electromagnetic field is a combination of a traveling magnetic field BW and electric field E caret. The stationary field E, created by the line charges, is perpendicular to the traveling wave. Asterisk DEABW plus EW, a DT equals C, force volume, where E is the linear capacitance of space and C is the speed of light. Thus there is a force per volume around the hull, left bracket 0010 right bracket. This combination of fields produces a spacetime curvature as determined by EINS general theory of relativity. The traveling electric field has an amplitude in the vertical z direction, and travels in the x direction W as CS *0. The Faraday electromagnetic tensor contains all the electric and magnetic fields in all the XYZ directions. The first row and first column contain the two electric fields greater than \0 ZIEZCOIXE 0 EZ cos.V1 0.000000000. The stress exerted on spacetime occurs in the XX, Y and ZZ direction, as calculated from the stress energy tensor T of Gravitational Physics 4 and V * equal FMFFFFs, where G is the metric tensor for Cartesian space R gap tilde XYZ minus 10 0 0 0 1 0 0 0 0 1 0 0 0 0 1, where the diagonal components are the coefficients of the elementary spacetime length ds squared. ds2 equal dt, 2 plus dx, 2 plus df plus dz. 2 The calculation produces three stresses txx, tei, and tzz in their respective xyz directions, left bracket 0011 right bracket, referring to Fig. 6. These three stresses are plotted together as a 3D vector field, animated over time in 9 frames. The graphs show that there is a lift force, as depicted by the vertical arrows, as well as a force of propulsion, as shown by the interspersed horizontal arrows. With the passage of time, these vectors exchange places with each other so that the lift becomes the propulsion, and vice versa, creating a wavy stress energy field around the hull. Summary of the invention, left bracket 0012 right bracket. This invention is a spacecraft with a triangular hull having charged flat plates on the vertical comers of the three sides. The two rear comers are charged to a potential V. The forward comer is charged to a potential V. The 6-0 angle on the comer creates a line charge density singularity that produces a huge horizontal electric field, pointing from the back to the front of the craft, which is also parallel to the sides of the triangle. An array of horizontal slot antennas located on the sides of the triangular hull produce an electromagnetic wave with the electric field polarized in the vertical direction. This combination of fields produces a spacetime force in both the vertical and horizontal direction such that the spacecraft receives a lift force and a force of propulsion. A brief description of the drawings, left bracket 0013 right bracket Fig 1. Perspective view of triangular spacecraft, left bracket 0014 right bracket Fig 2. Drawing of the intersection of two charged plates in order to calculate the charge density in the comer. Left bracket 15 right bracket Fig 3. Perspective view of the corner angle, left bracket 5 for the equilateral triangle, left bracket 0016 right bracket Fig 4. Planar 2D graph showing the electric field produced by three line charges on the comers of the triangular hull. Left bracket 17 right bracket Fig 5. Perspective view of electric field produced by the linear charge interacting with the traveling electromagnetic wave produced by the slot antenna, left bracket 0018 right bracket Fig 6. 3D vector animation of the lift and thrust force generated by the fields, left bracket 0019 right bracket Fig 7. Perspective view of slot antenna. Detailed description of the invention, left bracket 0020 right bracket, referring to Fig 7. The antenna A is made out of sheet copper, in which a rectangular horizontal slot B has been notched out using a die press and sheet metal fixture. A coaxial cable from the amplifier and frequency generator is attached across the slot by soldering the outer cable D to one side of the slot and the inner cable E to the other side of the slot. This creates the positive and negative charges across the gap, which forms the vertical electric field F, which radiates out perpendicularly to the copper sheet. July 6, 2006 left bracket 0021 right bracket. Although the invention has been described with reference to specific embodiments, such as a particular antenna system, those skilled in the art will appreciate that many modifications and variations are possible without departing from the teachings of the invention. All such modifications and variations are intended to be encompassed within the scope of the following claims. 1. A spacecraft comprised of the following components. A triangular hull, in the form of an equilateral triangle. B. Two copper plates attached on opposite vertical sides at each of the three comers of the hull, such that a sharp vertical edge is formed where they come together. C. An electrostatic generator used to charge the back two copper-cladded corners LB to a high positive voltage, and the third forward copper-cladded corner to a high negative voltage. D. A horizontal slot antenna array mounted on the sides of the hull. And B. A frequency generator, antenna and coaxial cables to drive the antenna array. 2. To create, by claims LB, an intense vertical line charge at the comers 15 and a horizontal electric field that is parallel to the sides of the hull. 3. To create, by claims LD, an electromagnetic wave with a vertically polarized electric field traveling outward from the side of the hull. And 4. To create, by claims 2-3, an interaction of the electrostatic field 2 with the electromagnetic wave 3, such that a combined spacetime curvature pressure is generated on the hull in the upward and forward direction to produce lift and propulsion respectively.